Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 12 video where I will solve another set of 6 multiple choice questions based on the concepts that I discussed in part 10 video, how to compare exponential terms like a to the power m, b to the power n and c to the power p, where abc and m and p are all natural numbers. If you have missed the part 10 video, then I strongly suggest that you please watch that video. Then you will be able to understand the solution of these problems. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends. And if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 12 video where I will solve another set of multiple choice questions regarding comparison of exponents, which is based on part 10. Okay. So essentially all these problems are, most of the problems are based on how do we compare exponential terms like a to the power m, a to the power m, b to the power n and c to the power p, where a, b, c and m and p, they are all natural numbers. Okay. So the first problem says, what is the least integral value of x such that 3 to the power 2x is greater than 625. Now, so what will be the least integer value of x that will satisfy this inequality? So this is an inequality. Now on the left hand side I see the base is 3 and the unknown variable is in the power. On the right hand side I know it is 625. 625 cannot be expressed as a power of 3. Now so we have to use a little bit trick. So it is given sorry, so it is given 3 to the power 2x. Now 3 to the power 2x can be written as 3 to the power x whole raised to the power 2, that is square of 3 to the power x is greater than, now I know that 625 can be expressed as a square, and I think it is 25 square. So I have 3 to the power x whole raised to the power 2 greater than 25 square. This implies definitely we must have 3 to the power x greater than 25. Now you have since x is an integer value, you have to substitute, you have to consider values of x and see what is the least integer value of x such that 3 to the power x is greater than 25. Now 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27. 3 to the power so definitely x will be equal to 3, because at 3 is the least number where we are seeing that 3 to the power x or 3 to the power x is greater than 25. 3 to the power 3 is 27, which is greater than 25. So x, the value of x is 3. Let's see the next problem, which is greater between 5 to the power 1014 and 9 to the power 676. Now we see that both the bases 5 and 9 are quite different. They cannot be expressed in exponential term with a common base. So I have to now think about taking the HCF of the powers. So what is the HCF of the powers? That is 1014 and 676. 676 1014. I think no 4 8 no okay, so I'm dividing by 2, 3 8 and this is 507. 507 and 338. 7, no. It's not dividing by 3. 9, 57, no. Okay, so how do we find the HCF? I forgot how to find the HCF of two numbers. What was that method? 676 divided by 1014. 676. This is 8, 3, 4, 7, 3, and I will divide again 676. Okay, so I see this is 16. Okay, so the HCF is, I guess, 338. The HCF is 338. 8, 3. Yes, it is 338. Okay. So now I will express the two given exponential terms to have a power of 338. So I know this is 5 to the power 1014 is 338 multiplied by 3, and 9 to the power 67 is 676 is 338 multiplied by 2. So now this becomes 5 cube whole raised to the power 338, and this is 9 square whole raised to the power 338. The idea is to when I see that the powers are having an HCF greater than 1, then I will express both the numbers, given numbers, in the exponential form to have a power which is equal to the HCF of the powers of the given numbers. In this case, the HCF of 1014 and 676. So once the powers are same, I will now compare them by the base. I know, so this is equal to 125, 5 cube is 125, 125 to the power 338, 9 squared is 81, 338. Now since 125 is greater than 81, then obviously 125 to the power 338 will be the greater number. So they can say that this 5 to the power 1014 is the greater number. Let's see the next problem. Arrange the numbers in ascending order. Now you can see that there is radical terms, but if you simplify them, the expressions, you will find that all the numbers will be transformed into exponential terms with integers as powers. So square root of 3 whole raised to the power 30 is, square root of 3 is 3 to the power 1 by 2. 3 to the power 1 by 2 whole raised to the power 30 becomes 3 to the power 15. Let's see square root of 27, and also I see all the radicals, that is the number inside the radical sign, they can all be expressed as a power of 3, because we have 3, 27 and 81. So square root of 27 to the power 4 is square root of 27 is 27 to the power half, and we have whole raised to the power 4. So this is 27 square. Now 27 can be expressed as 3 cube. So this becomes 3 to the power 6. So the idea is to convert all the given numbers as integral power of 3. Okay. Now square root of 81 whole raised to the power 8 is equal to 81 to the power half, this whole raised to the power 8. This is 81 raised to the power 4, and this is 81 is 3 to the power 4 raised to the power 4. So this is 3 to the power 16. So clearly we see that all the numbers has been transformed into exponential terms where the base is 3 and the powers are 15, 6 and 16. Quite obviously 3 to the power 6 will be the smallest number, and then the number then the next number in the ascending order will be 3 to the power 15 and then finally 3 to the power 16. So the numbers when arranged in the ascending orders will be square root of 27 to the power 4 is less than square root of 3 to the power 30 is less than finally square root of 81 to the power 4. So this is the given numbers in ascending order. Let's see the next problem. Question number 4. Identify the greater between. Okay, so we have to compare. It is 2 square, this whole raised to the power 3, and this is 2. Now this, I hope you know what is this. This number is actually 2 is raised to the power, and the power is again an exponential term, which is 2 raised to the power 3. So this is actually, if I so this is 2 raised to the power 2 to the power 3 is 8. So this, okay. Now if I further simplify the first number, this will be 2 to the power 6 and we have 2 to the power 8. Clearly we see both the exponential terms are having same base, so we will compare them by their powers. So clearly, since 6 is less than 8, this implies 2 to the power 6 will be less than 2 to the power 8. Hence the greater number is 2 to the power 8, which is, so this number is the greater number. Let's see the next problem. Arrange 6 to the power minus 3, 5 to the power minus 3, 4 to the power minus 3 and 3 to the power minus 3 in ascending order. Okay. Now we can see that all the powers are same. Even though the powers are negative, all the powers are same. Okay. One concept you must know is that if x and y are two natural numbers, and if x is greater than y, this will imply that x to the power, and the power is a negative integer, minus n will be less than y to the power minus n. If x and y are natural numbers and n is also a natural number and x greater than y, will imply that x to the power minus n will be less than y to the power minus n. Why? Because from here we will get x to the power n, where n is a natural number, should be greater than y to the power n. Now if we have this, their reciprocal, if we take the reciprocal, the inequality sign will get reversed. This implies 1 by x to the power n will be less than 1 by y to the power n, which is nothing but x to the power minus n is less than y to the power minus n. So we can, using this concept, we can say that since we have, if you see the base, if we arrange the base in the ascending order, we will have 3 less than 4 less than 5 less than 6, and the moment we raise all these numbers, that is 3, 4, 5 and 6, to a negative power, that is negative integer, the inequality sign will get reversed. Any negative any negative integer. So when I do 3 to the power minus 3, this will be greater than 4 to the power minus 3, this will be greater than 5 to the power minus 3, this will be greater than 6 to the power minus 3. This implies if we arrange the given numbers in the ascending order, it will be 6 to the power minus 3 is less than 5 to the power minus 3 is less than 4 to the power minus 3 is less than 3 to the power minus 3. Let's see the next problem. I think, okay, there are how many questions? Oh, there are 10 questions. Oh, okay. Question number 6. Find the least integer value of x which satisfies x to the power 4 is greater than 1000. Now, there is as such no any trick or method to how to solve for this inequality. This is an inequality because there is a greater than sign. Now, also I cannot, as you can see on the left hand side, it is x to the power 4, and on the right hand side 1000 cannot be expressed as a power of 4. If on the right hand side the number was such that I could express that as a power of 4, things would be much easier. So in this scenario, since it is given that the x is a integer value, you have to assume you have to solve the value of x by trial and error, by putting the values of x as 1, 2, 3, 4. So x to the power 1 1 to the power 4 is obviously 1, 2 to the power 4 is 16, 3 to the power 4 is 81, 4 to the power 4 is 256, 4 to the power 4 is 256, 5 to the power 4 is 625, 5 to the power 4 is 625, okay, and 6 to the power 4 is 6 cube is 216, so 216 multiplied by again 6, 36, 1296. So we see 6 to the power 4 is 1296. So clearly we see that the least value of x such that x to the power 4 is greater than 1000 should be 6. Hence x is equals to 6. This is the only way you have to solve this kind of problem. You have to put the values of x as 1. Since x is an integer value, you have to keep on putting the values of x as 1, 2, 3, 4 and see at what value of x you are getting that power of 4 is greater than 1000. Okay, let's see the next problem. It is given that 432 is greater than 2 to the power 2 multiplied by y cube. Now, okay, so first of all I will divide both the sides by 2 and I get 216 is greater than y cube. Now I will see if I can express the left hand side number 216 as a power of 3. If I can, it will be easier to solve. 216 is obviously 6 cube. So I have 6 cube greater than y cube, and I know this will imply when the powers are same, and if the powers are same, so I already discussed in the part 10 video that x to the power m, if it is given x to the power m is greater than y to the power n, the powers are same, then this will imply x will be greater than y. So applying this concept, we must have 6 should be greater than y. This implies y is less than 6, and the problem has asked what is the greatest possible value of y. So y is less than 6 and y is an integer, so y is 5. The greatest value of y such that y is less than 6 is the greatest integer value of y such that y is less than 6 is obviously y equals to 5. Let's see the next problem. X to the power 5 less than 1000 is very similar to question number 6. We have to put values of x as 1, 2, 3, 4 and see at what value of x you are having x to the power 5 less than 1000. Okay, we have to find the greatest integer value of x, but in the earlier problem we were asked to find the least value of x. So we see, let's not consider, we know that, okay, so this time the power is 5. Okay, how much is 4 to the power 5? Let's see. 4 to the power 5 is 4 cube is 4 to the power 4 is 256. 256 multiplied by 4, 24. Okay, 1024. So we can see 4 to the power 5 is 1024. Greatest integer value such that, okay, what is 5 to, so definitely is greater than this. Now I need to check whether 3 to the power 5 is also greater than less than. We have to find the greatest integer value of x such that x to the power 5 is less than 1000. Now 4 to the power 5 is 1024, so which is not, 1024 is not less than 1000, so definitely we cannot consider 4. So let's see what is 3 to the power 5. 3 to the power 5 is 3 to the power 4 is 81, and 3 is 243. What is the, find the greatest integer value of x? Four to the power 5 is 1024. 625. 4 to the power 5 is 4 to the power, how much is 4 to the power 4? 4 to the power 4, 16 square. 16 square is 256. And 256 multiplied by 4 is 1024. Yeah, I think so. We can see that the greatest value of x such that x to the power 5 is less than 1000 should be x is equal to 3, because when x equals to 4, 4 to the power 5 is 1024, which is greater than 1000. So the greatest value of x is 3. Let's see the next problem. Arrange these numbers in ascending order. We can see that the bases are cannot be expressed as power of the same number. So we have to think about, we have to see whether we can find whether the HCF of the powers of the given numbers is greater than 1 or not. Clearly, okay, so 512 multiplied by 2 is 1024. 512 multiplied by 2 is 1024. Okay. So basically, essentially, I have to find the HCF of 512 and 768. 512, 768, 1, 512, 6, 5, 256, 512, 2, 12, 11, 5. So 256 is the HCF of, so the HCF of the powers of the given numbers 768, 1024 and 512 is equal to 256. So I will transform all the given numbers to a power of 256. So 3 to the power 768, 768 is 256 multiplied by 3. 2 to the power 1024 is 256 multiplied by 4, and 512 is 256 multiplied by 2. After further simplifying, we get the first number as 3 cube whole raised to the power 256. The second number will be 2 to the power 4 whole raised to the power 256. The third number is 5 square whole raised to the power 256. So now I have all the numbers has been transformed into exponential term where the powers are same, that is 256. So now I will only compare the bases. So this is 3 cube is 27, 27 to the power 256, 2 to the power 4 is 16, 16 to the power 256, and 5 squared is 25. Now we can clearly see that the 16, comparing the bases, we have 16 less than 25 less than 27. So this implies 16 to the power 256 will be less than 25 to the power 256 will be less than 27 to the power 256. Now this implies, what was the original number of 16 to the power 256? 16 to the power 256, the original number was 2 to the power 1024. So we have 2 to the power 1024 less than 25 to the power 256. The original number was 5 to the power 5 to the power 512, and finally we have, this should be less than 3 to the power 768, 3 to the power 768. So this is the given numbers in ascending order. Let's see the last problem, which is the greatest among the given numbers. We can clearly see that all the bases can be expressed as power of 5. Now so 5 to the power 23, the second number is 5 square to the power 11, the third number is 625 is 5 to the power 4 to the power 6, and what is 3125. So see, 625 multiplied by 3 multiplied by 5 is 3125. 25 yes, 31. So 625 is 5 to the power 25 square 4 5. This whole raised to the power 6. So now if I further simplify the numbers, it becomes 5 to the power 23 25 sorry this is 5 square whole raised to the power 11 means 5 to the power 22, 5 to the power 24 and 5 to the power 30. So now all the given numbers has been transformed into exponential terms where the bases are same. So now we will just compare them by the powers. So I know 22 is less than 23 is less than 24 is less than 23. So this will imply 5 to the power 22 will be less than 5 to the power 23, will be less than 5 to the power 24, will be less than 5 to the power 30. So this implies 5 to the power 22, the original number was 25 to the power 11. 5 to the power 23, the original number was 5 to the power 23 only. And 5 to the power 24, the original number was 5 to the power 24. 5 to the power 24, the original number was 625 to the power 6. And finally we have 5 to the power 30, the original number was 3125 to the power 5. So this is the given numbers in ascending order. So this is the greatest number. So with this, it comes to an end in solving another set of 10 problems based on the comparison of exponential terms like a to the power m, b to the power n, c to the power p, where abc and m and p are all natural numbers. If you find this video beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about how to compare some numbers which are in the radical form. That is, all the numbers are radicals. That is, comparing numbers like a to the power 1 by m, b to the power 1 by n, and c to the power 1 by p, where abc are some real numbers, or maybe, let's say, to be very specific, they are natural numbers, and m and p are obviously some natural numbers. How do we compare these kind of numbers? Now these numbers are basically radicals. That is, the first number is mth root of a, the second number is nth root of b, and the third number is pth root of c. So this video is coming soon, so please stay tuned. I am ending the video here. Thanks for watching, and until the next video, take care and bye.